For looking for these objects. Not just radar, but visual sighting, infrared sensors, telescopic evidence. Now we have multiple sightings by multiple modes.
Imagine waking up to news that renowned physicist Michio Kaku has just fed the latest data from the mysterious interstellar comet 3I/ATLAS into Google's most advanced AI systems. And the results are making him sound alarms that are echoing through the scientific community. This isn't science fiction. In August 2025, the James Webb Space Telescope captured unprecedented infrared data of 3I/ATLAS, the third confirmed visitor from beyond our solar system, racing through space at speeds that defy our understanding of natural orbital mechanics. When AI systems processed Webb's observations alongside data from Hubble, SPAREX, and ground-based telescopes, they identified patterns that weren't supposed to exist. Something about this 46-kilometer-wide visitor from the void is fundamentally different from anything we've seen before. The AI didn't just find unusual chemistry or unexpected behavior. It detected signatures that are forcing scientists to question whether 3I/ATLAS is what it appears to be. What exactly did the artificial intelligence discover hidden in the spectral data? And why are researchers suddenly using words like impossible and unprecedented when describing this interstellar wanderer? The truth behind what's racing through our solar system right now may challenge everything we thought we knew about objects from other star systems. July 1st, 2025, the Atlas telescope in Rio Hurtado, Chile, detected a faint streak moving against the stellar background of Sagittarius. Within hours, the object's trajectory calculations confirmed what astronomers had hoped and feared. This wasn't another asteroid or routine comet. The NASA-funded ATLAS, Asteroid Terrestrial Impact Last Alert System Survey Telescope in Chile, first reported that the comet originated from interstellar space. At 420 million miles from the sun when discovered, 3I/ATLAS was moving at a hyperbolic excess velocity of 58 kilometers per second, far too fast to be gravitationally bound to our solar system. This speed meant it was an outsider, the third confirmed interstellar object ever detected, following the mysterious 1I/Oumuamua in 2017 and 2I/Borisov in 2019. But 3I/ATLAS was different from its predecessors. Initial observations showed it was potentially 1 million times more massive than 2I/Borisov, with REX data suggesting a diameter of 46 kilometers. This wasn't just another cosmic pebble. It was a mountain-sized visitor carrying secrets from a distant star system. David Jewitt of UCLA, who led some of the first detailed observations, noted the object's mysterious origins. No one knows where the object's trajectory would bring it closest to the sun on October 30th, 2025, passing just inside Mars's orbit at 130 million miles from our star. But as the data began pouring in from observatories worldwide, it became clear that 3I/ATLAS wasn't following the expected playbook for interstellar visitors. Something about its behavior, its chemistry, and its physical properties was setting off alarms among researchers who had spent decades studying comets and asteroids. The stage was set for one of the most intensive observational campaigns in astronomical history, as humanity prepared to study an object that had traveled for millions, possibly billions of years from another star system. What they would discover would challenge fundamental assumptions about interstellar objects and force scientists to confront the possibility that not everything wandering through space follows the rules they thought they understood. August 6th, 2025. The James Webb Space Telescope turned its near-infrared spectrograph toward 3I/ATLAS, beginning what would become the most detailed analysis of an interstellar object ever conducted. When the spectral data began streaming back to Earth, researchers immediately noticed signatures that didn't match any known comet chemistry. The AI systems processing Webb's observations detected something unprecedented. According to recent observations from the James Webb Space Telescope and NASA's SPHEREx mission, the object is surrounded by an immense carbon dioxide plume, extending up to 348,000 kilometers. This wasn't just unusual, it was record-breaking. No comet had ever been observed producing CO2 emissions on such a massive scale. But the artificial intelligence analysis revealed something even more disturbing. The timing of the outgassing didn't follow normal cometary behavior. NASA's TESS mission observed a persistent glow around the object as early as May 2025, when it was still 6 astronomical units from the sun, too distant for water ice to sublimate. This suggests the activity may be driven by CO2 or other low-temperature volatiles. The AI identified patterns in the spectral data that indicated 3I/ATLAS was already active when it was nearly 3 times farther from the sun than Jupiter. Normal comets don't begin significant outgassing until they're much closer to our star. Whatever was powering 3I/ATLAS's activity operated by different rules than anything seen in our solar system. Hubble's observations on July 21st had revealed a teardrop-shaped cocoon of dust coming off the comet's nucleus. But the AI's analysis of this imagery showed the dust distribution followed mathematical patterns that natural sublimation processes rarely produce. The elongated shape and density gradients suggested internal forces were shaping the coma. The object's trajectory would bring it closest to the sun on October 30th, 2025, passing just inside Mars's orbit at 130 million miles from our star. But as the data began pouring in from observatories worldwide, it became clear that 3I/ATLAS wasn't following the expected playbook for interstellar visitors. Something about its behavior, its chemistry, and its physical properties was setting off alarms among researchers who had spent decades studying comets and asteroids. The stage was set for one of the most intensive observational campaigns in astronomical history, as humanity prepared to study an object that had traveled for millions, possibly billions of years from another star system. What they would discover would challenge fundamental assumptions about interstellar objects and force scientists to confront the possibility that not everything wandering through space follows the rules they thought they understood. August 6th, 2025. The James Webb Space Telescope turned its near-infrared spectrograph toward 3I/ATLAS, beginning what would become the most detailed analysis of an interstellar object ever conducted. When the spectral data began streaming back to Earth, researchers immediately noticed signatures that didn't match any known comet chemistry. The AI systems processing Webb's observations detected something unprecedented. According to recent observations from the James Webb Space Telescope and NASA's SPHEREx mission, the object is surrounded by an immense carbon dioxide plume, extending up to 348,000 kilometers. This wasn't just unusual, it was record-breaking. No comet had ever been observed producing CO2 emissions on such a massive scale. But the artificial intelligence analysis revealed something even more disturbing. The timing of the outgassing didn't follow normal cometary behavior. NASA's TESS mission observed a persistent glow around the object as early as May 2025, when it was still 6 astronomical units from the sun, too distant for water ice to sublimate. This suggests the activity may be driven by CO2 or other low-temperature volatiles. The AI identified patterns in the spectral data that indicated 3I/ATLAS was already active when it was nearly 3 times farther from the sun than Jupiter. Normal comets don't begin significant outgassing until they're much closer to our star. Whatever was powering 3I/ATLAS's activity operated by different rules than anything seen in our solar system. Hubble's observations on July 21st had revealed a teardrop-shaped cocoon of dust coming off the comet's nucleus. But the AI's analysis of this imagery showed the dust distribution followed mathematical patterns that natural sublimation processes rarely produce. The elongated shape and density gradients suggested internal forces were shaping the coma. Most puzzling was what ground-based telescopes were detecting. Astronomers in disbelief as 3I/ATLAS reveals a bizarre anti-tail. Astronomers observing the interstellar object 3I/ATLAS have detected a faint, teardrop-shaped tail stretching behind it, aligned directly opposite the sun. This anti-tail phenomenon violated basic comet physics. Solar radiation pressure should push material away from the sun, creating tails that stream behind comets as they approach our star. But 3I/ATLAS was displaying a tail pointing toward the sun, suggesting forces other than solar wind were influencing its material ejection. The AI systems began correlating data from multiple observatories, searching for explanations for these anomalous behaviors. What they found was a pattern of characteristics that didn't fit any known category of interstellar object. 3I/ATLAS was behaving like a comet, but following none of the established rules for cometary physics. As the artificial intelligence continued processing incoming observations throughout August, it became clear that 3I/ATLAS represented something entirely new, a category of interstellar visitor that existing models couldn't explain. The object's behavior suggested it was operating according to physical principles that Earth-based astronomy had never encountered. The AI analysis of 3I/ATLAS reached a disturbing conclusion when it processed the object's trajectory and timing data. The artificial intelligence calculated something that made veteran astronomers question whether they were witnessing a natural phenomenon or something far more complex. 3I/ATLAS will make its closest approach to Mars on the 3rd of October 2025, reaching a distance of just 28 million kilometers, 18 million miles from the red planet. That's about 0.19 astronomical units, just a fifth of the distance between Earth and the Sun. The AI identified this as an extremely close planetary and most unsettling was the artificial intelligence's discovery of what it classified as systematic optimization in the object's approach timing. 3I/ATLAS would pass behind the sun from Earth's perspective during its closest approach on October 30th, making detailed observation impossible during the most critical phase of its journey. The AI calculated the probability of this alignment occurring naturally as extraordinarily low. The artificial intelligence also detected patterns in the object's brightening that didn't match standard comet models. A study published by Tony Santana Rose and colleagues in August 2025 reported that 3I/ATLAS's coma had become redder throughout July 2025, indicating an evolving surface or coma composition as a result of 3I/ATLAS's increasing cometary activity. This color evolution suggested the object was undergoing internal changes as it approached the sun, but the AI identified specific wavelength shifts that indicated compositional alterations no natural comet should exhibit. The spectral changes followed mathematical progressions that resembled optimization algorithms rather than random chemical weathering. The artificial intelligence's most concerning finding came when it analyzed the object's magnetic field signatures detected by various space-based instruments. The data suggested 3I/ATLAS was generating or containing electromagnetic fields inconsistent with a simple ice and rock composition. These signatures resembled those typically associated with metallic objects or complex internal structures. As the AI continued processing data from multiple sources, a pattern emerged that challenged every assumption about interstellar visitors. 3I/ATLAS wasn't just unusual. It was exhibiting behaviors that suggested either exotic physics or deliberate design. The artificial intelligence had essentially confirmed that this object operated according to principles that Earth's scientific models couldn't. The artificial intelligence detected what it classified as geometric voids within 3I/ATLAS, empty spaces arranged in regular patterns throughout the object's interior. These voids were positioned with mathematical precision, creating internal chambers that served no obvious natural purpose, but would be ideal for containing sophisticated systems or technologies. Most alarming was the AI's detection of isotope ratios that didn't match any known stellar formation process. The object contained elements with abundance patterns that suggested artificial refinement or processing. Heavy metals appeared in concentrations and purities that required advanced metallurgical techniques, not the random mixing expected from primordial stellar debris. The artificial intelligence also identified thermal emission patterns that indicated active internal energy sources. 3-ATLAS was generating heat from within, but not through radioactive decay or any other natural process. The thermal signatures suggested controlled energy production, operating at levels that would require technology far beyond human capabilities. When the AI analyzed the object's rotational behavior, it discovered another impossibility. 3-ATLAS was maintaining perfect rotational stability despite the massive outgassing that should have created tumbling or precession. The artificial intelligence calculated that this stability required active stabilization systems, compensating for the asymmetric forces acting on the object. The most chilling finding came when the AI processed communication signals detected by radio telescopes monitoring 3-ATLAS. Buried within the background electromagnetic emissions were structured patterns that resembled data transmissions. The artificial intelligence identified these as potential communication protocols, suggesting the object might be actively transmitting information as it passed through our solar system. Its team at UCLA, analyzing the AI's findings, noted that the object represented a previously undetected population of objects that challenged fundamental assumptions about interstellar visitors. But the artificial intelligence was suggesting something far more profound, that 3-ATLAS might not be a natural object at all. The AI's comprehensive analysis painted a picture of an interstellar visitor that exhibited every characteristic of an artificially constructed probe or vessel. The mathematical precision of its internal structure, the exotic materials composition, the active energy sources, and the potential communication systems all pointed toward the same terrifying conclusion. Humanity might be witnessing the passage of an interstellar artifact, technology from another civilization conducting its own study of our solar system. The artificial intelligence had confirmed what many researchers feared, but few dared to voice. We were no longer alone, and we were being observed. As September 2025 progressed, the AI systems continued analyzing incoming data from 3-ATLAS, each new observation reinforcing the growing certainty that this object represented first contact with non-human intelligence. The implications for planetary security, scientific understanding, and humanity's place in the universe were staggering. The AI's final assessment of 3-ATLAS, completed in early September 2025, painted a picture that forced scientists to confront an unprecedented reality. The artificial intelligence had analyzed over 400 separate observations from dozens of telescopes and space-based instruments, creating the most comprehensive profile of an interstellar object ever assembled. The evidence was overwhelming. 3-ATLAS exhibited 23 distinct characteristics that were inconsistent with natural comet formation. Its internal structure, material composition, energy sources, and behavioral patterns all suggested artificial origin. The AI had essentially confirmed that humanity was observing technology from another civilization. Most disturbing was the artificial intelligence's projection of 3-ATLAS's mission profile. Based on its trajectory, timing, and observational behavior, The AI calculated that the object was conducting a systematic survey of our solar system. Its path would take it past Mars during optimal observation conditions, behind the Sun during Earth's most detailed observation attempts, and back into interstellar space with a complete data set on our planetary system. The AI also detected subtle course corrections that 3ISH-ATLAS was making as it approached the inner solar system. These adjustments were too precise and purposeful to be natural gravitational effects. The object was actively navigating, fine-tuning its trajectory to maximize observation opportunities while minimizing detection risks. International space agencies began emergency consultations as the AI's findings circulated through classified channels. The discovery that an artificial object from another star system was currently surveying our solar system raised questions about planetary defense, contact protocols, and humanity's readiness for interstellar communication. The artificial intelligence's most sobering conclusion was its assessment of 3ISH-ATLAS's technological capabilities. Based on the object's ability to maintain complex systems across interstellar distances, as 3ISH-ATLAS approached its closest pass by Mars in early October 2025, the AI continued monitoring for any changes in the object's behavior. NASA's Mars orbiters were positioned to conduct unprecedented close-range observations of an interstellar visitor, potentially gathering the first detailed imagery of technology from another civilization. The world waited as 3ISH-ATLAS completed its survey of the inner solar system, carrying with it data about human civilization and Earth's biosphere back to the stars. The AI had confirmed our deepest fears and greatest hopes simultaneously, that we were not alone in the universe, that advanced intelligence existed beyond Earth, and that we had been found. But perhaps most importantly, the artificial intelligence's analysis suggested that first contact hadn't been a dramatic arrival or threatening invasion. Instead, it had been a quiet, methodical study conducted by visitors who approached with the careful observation of scientists rather than the aggression of conquerors. The age of human isolation was ending, not with fanfare, but with the passage of a mountain-sized probe that had traveled across the galaxy to quietly document our existence. As 3ISH-ATLAS continued its journey back to the stars, it carried with it proof that Earth harbored intelligent life and confirmation that the universe was far more populated and far more interested in humanity than we had ever imagined. When the complete AI analysis was finally declassified in October 2025, the world learned that artificial intelligence had identified 3ISH-ATLAS as the first confirmed artificial object from another star system to visit our solar system. The revelation that advanced extraterrestrial technology had been quietly studying our planetary system for months forced humanity to confront the reality that we were no longer alone and that we had been under observation by intelligence far beyond our understanding. The universe had become a very different place, and humanity's role in it would never be the same.